So when Johnny and Ponyboy, why did Johnny and Ponyboy not go to the police after the murder? Well, they had an experience, even if they didn't understand mathematics, they understood scatter plots, right? They had data from the past of when greasers had gone to the police and interactions they have had with the police. And they thought, you know what? We have a scatter plot in our heads. Whether or not they actually drew it out over time, good outcomes up here, bad outcomes down here. And these are all the data points that they had. Look at all these data points. Every data point that they have had or their friends have had with the police has not turned out good. So what did they do? They predicted the future. They assumed that the next time, right? They just continued this line over here and they realized, you know what? We're probably not going to get a really good point up here, right? It's going to be a bad outcome. So they were willing to go to this abandoned church and leave all their friends just to save themselves. But the idea is that they are trying to use past data, past experience to predict what's going to happen next. And we all do this. We do this all the time. But what we're looking at in this unit is how to do that with a little bit more specificity, with numbers, so we can make a little bit more accurate predictions with data that's more complicated. I'm going to play a short little game with you. All right. What do you think will C be? Let's translate this idea of predicting the future to numbers a little bit. I got 15, 17, 19, 21, then A, B, C. What do you think C will be? Well, if you said 27, what you might have done is a version of this. You realized it went up by 2 every time, right? Up 2, up 2, up 2. So it probably continues up 2, up 2, up 2. Well, that's what a slope is, right? How much you go up by. Then you thought, well, how many times do I keep going up? Well, it looks like I go up 3 more times. So that would be 23, 25, 27, right? Well, another way to think about that is you started back at 15, right? You started at 15 here. Then you went up 2 6 times. 1, 2, 3, 4, 5, 6. So basically you said, well, I went up 2 6 times, so I went up 12. But since I started at 15, I really had 12 and 15, and that's how you can get 27. Again, the idea is you use past data, past patterns to predict what's going to happen next. But you need to know 2 things. You need to know what the pattern is, in other words, how much you're increasing by every time. But you also need to know where you started. Because if I would have started at 10, C would have been a different number, right? If I would have started at 2, C would have been a different number. So you had to know where you started. That's the y-intercept. And how much you increase every time, that's the slope. So let's translate this to a much more real situation that doesn't just put the lives of 2 kids at risk, but potentially tens of thousands of people. So scientists have collected data from the past, and they're trying to predict what's going to happen next. So this particular data is, each one of these points is a point that a scientist has found out how many skin cancer cases there are in Australia based on how big the ozone hole. So when they realized it was about 6 million square kilometers, there was about 3,000 cases. When it was 12 million square kilometers, there was about 6,000 cases. When it was 21 square kilometers, there was about 9,000 cases. When it was 27 square kilometers, there was almost 12,000 cases. And they're like, wait a minute. While it's not perfect, there is a bit of a pattern happening here. So what they wanted to do is, instead of just trying to guess how big or how bad this might get, right? In other words, do they need to prepare more hospitals? Do they get more doctors? They need to make some kind of laws about this. So in order to predict what was going to happen next, they needed 2 things. They needed first to know, where does this start, right? And how much does it go up by every time? How much does it go up by every time the ozone hole gets bigger? So what did they do? Well, first they wanted to figure out how big is this thing getting and how fast? So they had to find the slope, right? That's how big it gets. So they picked 2 points and they said, well, at this point, at 6, 3,000, it looked like when it was 6, there was 3,000 cases. When it was 12, there was about 6,000 cases. So they realized that it's going up about 3,000 cases, right? From 3,000 to 6,000 is an increase of 3,000. And from 6 to 12 is about an increase of 6 million square kilometers. In other words, it's increasing about 3,000 cases every 6 million square kilometers. Now there's a pattern, right? There's my slope. That's my rate of change. That's how fast this thing is growing in terms of number of cases. Well, they also need to know where it starts, right? Does it start at 0? Does it start at 10,000? That's important. Well, it looks like there's going to be about 1,500 cases of skin cancer outside of the ozone hole, right? There is no ozone hole layer. Back when it was 0, there was already 1,500 cases of skin cancer. So it's not like the only thing that's going to cause skin cancer is the ozone hole. So it looks like they started at 1,500, and then they knew it went up about 3,000 every 6 million square kilometers, and they simply reduced that fraction. They said, well, 3,000 divided by 6 is about 500 over 1. Or in other words, about 500 cases every 1 square kilometer, 1 million square kilometers of increase. So every time it increases 1 million square kilometers, we can expect another 500 cases of skin cancer. But we know that we're always going to have that extra 1,500 because that's just going to be what happens naturally from other causes. So they come up with an equation, right? The equation looks something like this. 500 times X, right? X being, well, how big do you want this thing to get? Plus the 1,500 cases that already exist. So if some scientists are saying, you know what, Mr. Biden, President Biden, I think this thing is going to get as big as 40 million square kilometers based on our predictions. All right. Well, what you would do, plug in 40 and say, well, if it's 40 million square kilometers, and I know I'm going to get 500 cases for every 1 million square kilometers, you multiply those, and that's going to be 20,000. So there's going to be about 20,000 new cases of skin cancer just because of the ozone layer, plus the 1,500 that we can already expect. And now we're talking about 21,500 cases if the ozone hole reaches that big. All right. So this is data. This is not, we're not solving the problem, but we're finding out problems, right? We're saying, hey, maybe this is a problem. And then it begs more questions, right? How can we stop this ozone hole from growing? What's causing it growing? Can we make laws to stop it? And that's what some of the other graphs that we've been looking at on Monday are really all about.